vehicles. The heavy-duty transportation sector is way behind. That's because batteries don't have enough juice to power trucks and ships. So researchers are turning to ammonia for a potential solution.
While the world is looking to get away from internal combustion engines and towards battery electric vehicles or fuel cell vehicles for cleaner emissions, Guangzhou Automobile Group appears to want to do it all. During its annual technology showcase, the Chinese partner to Toyota showed off an engine powered by liquid ammonia. Does this mean we'll see more ammonia-powered ICE vehicles in the near future? Welcome to Evolutionary. Join us today as we are going to unveil everything you should know if this new ammonia engine could change the entire industry. Ammonia Engine. GAC has shown a fascinating liquid ammonia-powered combustion engine. It was created in collaboration with Toyota and investigates one alternative to traditional fuels. We've overcome the pain point of ammonia being difficult to burn quickly and put the fuel to use in the passenger car industry, GAC R&D Center engineer Kai Hongzhong told the press. Its societal and commercial value is worth anticipating. Shanwen Tao, a professor of chemical engineering and sustainable processes at the University of Warwick in the United Kingdom, is one of many studying ammonia as a car fuel. Long-distance vehicles, the fuel cell technology, particularly ammonia, have huge advantages over batteries, Prof. Tao explains. Ammonia is easily transported in liquid form at ambient temperatures and under low pressure, and it is significantly less combustible than conventional fuels, making it easier to store. Furthermore, because of its chemical composition, it emits fewer emissions than typical fossil fuels such as gasoline or diesel. It is also worth mentioning that pure ammonia differs from ammonia in solution, which is utilized as a cleaning fluid in the home. Prof. Tao also claims that ammonia fuel cells are less expensive to manufacture than hydrogen fuel cells. Big progress has been made in direct ammonia fuel cells, so green ammonia is the rising star, in my opinion, he says. At its annual Technology Expo, the Chinese manufacturer displayed its special 2.0-liter engine. This engine is reported to produce 161 horsepower while generating 90% less carbon dioxide than a gasoline engine. This isn't the first time an ammonia-powered internal combustion engine has been constructed. It is already being investigated as an alternative fuel in a variety of industries, including marine engines and automobile fuel cells. The successful delivery of an ammonia fuel supply system for marine engines by Mitsubishi Shipbuilding in May demonstrated progress toward the adoption of this fuel. Furthermore, startups such as Ammonia Incorporated are investigating novel ways, such as converting ammonia to hydrogen before using it in fuel cells to power automobiles. But GAC's claims to be the world's first to investigate its possible usage in passenger cars. It has roughly half the energy density of gasoline, yet it does not release carbon, hydrocarbons, or carbon dioxide when burned. Despite claims of a world first, GAC is not the first to make a foray into this field. In the early 2010s, South Korean researchers experimented with engines that ran on a 70-30 ammonia-gasoline combination, with the intention of eventually converting regular cars to run on pure ammonia. Including some gasoline makes sense since it promotes burning in settings where ammonia's limited flame propagation speed causes problems. This is especially problematic at higher rate, when there is less time for combustion to occur. Ammonia's drawbacks. While ammonia is the fuel alternative, there are some things to be watched out for. There are risks using ammonia as a fuel source. Ammonia as a fuel source has two primary challenges. The first is obvious. It is a toxic substance. It is mostly utilized in agriculture, and ammonia is a solvent that may dissolve alkali metals, and prolonged exposure to ammonia in gas or liquid form can cause mortality in both humans and animals. According to the EPA, it is the main cause of fish kills. Because the transportation industry is already capable of handling the distribution and transportation of dangerous substances, it has been investigated as a diesel fuel substitute. There's also the issue of ammonia fuel producing a lot of nitrogen when used in an engine that isn't boosted or has a low compression ratio. It is also used in rocket engines, which are another business that uses hazardous compounds as fuels such as hydrazine and UDMH. The X-15 rocket-powered aircraft, flown to 4,520 miles per hour by William Knight, was the most renowned usage of ammonia as a rocket propellant. While you may identify ammonia with its nitrogen-rich relative ammonium nitrate, ammonia is very difficult to employ as a fuel in an ICE car. The liquid form of ammonia burns slowly, but has about one-third the energy density of diesel fuel at 37.95 kilowatt-hours per gallon. Because of its sluggish burn, it has an octane rating of 120, a flash point of 270 degrees, and an auto-ignition temperature of 1,203.8 degrees. On the other hand, gasoline has lower energy density, flash point, and auto-ignition temperature. When it does burn, it creates zero carbon dioxide, zero hydrocarbons, and zero soot. Don't get too excited just yet. Without an engine with a high compression ratio or boost, it emits a lot of nitrogen into the environment, which produces ammonia and ozone, which can cause acid rain and harm our capacity to breathe. Ammonia is hellish to handle, said Colin McCarricher, Bloomberg and EF's head of transportation and automotive studies. I can't see it taking off in passenger cars. With its toxicity issues, there just isn't the infrastructure to even fuel these engines. Despite the fact that hydrogen has a more difficult time than the EV charging infrastructure network, it may be significantly preferable to use ammonia in hydrogen production rather than as a combustible fuel for ICE vehicles. Major automakers, on the other hand, are currently focused on electrifying automobiles, especially through battery electric vehicles. The advancement of electric car technology has gained traction, with large investments in battery technology, charging infrastructure, and range extension. The increased availability of renewable energy sources, as well as the goal to reduce greenhouse gas emissions, are driving the emphasis on electrification. More research and development is needed to overcome these hurdles and make ammonia a viable fuel choice for passenger automobiles. Though the automotive industry is primarily focused on electric vehicle technologies, continued technological breakthroughs and collaborative efforts from multiple stakeholders may pave the road for ammonia to become a viable fuel choice in the future. Are there any alternatives? In a world economy shifting away from oil and gas, it's not just battery-powered electric vehicles that are gaining traction. Aside from ammonia, other alternative fuels include biodiesel, ethanol, hydrotreated vegetable oil, and hydrogen. According to Paul Hellier, an associate professor of engines at University College London who studies low and net zero carbon fuels, HVO, or renewable diesel, is increasingly popular and may be used without being blended with a fossil diesel. It now powers vehicles such as trash lorries. HVO is actually a very high-quality fuel relative to a fossil diesel or a standard biodiesel, Dr. Hellier says. Because of its composition, it may be suitable for use in aviation, an industry where electrification is less advanced than in road transport. HVO reduces greenhouse gas emissions by up to 90% when compared to regular diesel. However, it is often slightly more expensive. Another alternative fuel is hydrogen, which can be produced sustainably using renewable energy. However, it faces storage and transportation issues. A chemical reaction between hydrogen and oxygen powers an electric motor in hydrogen fuel cell electric vehicles, and the exhaust pipe emits water vapor. Toyota and Hyundai have already built hydrogen-powered vehicles, and other automakers, like BMW, have versions in the works or in limited production. In August, BMW chairman Oliver Zipse predicted that hydrogen will gain significantly in importance in terms of personal mobility. We believe hydrogen-powered vehicles are technologically ideally positioned to complement battery electric vehicles and complete the electric mobility picture, he added. Hydrogen combustion or fuel cell vehicles seem far more likely to catch on than ammonia cars, and even they're an outside chance. Still, GAC's engineers are getting paid and staying busy, and we're sure they're glad to be putting food on the table and beer in the fridge. We mentioned earlier about the hydrogen car, and we also know that currently the battery-powered car is fiercely entering the auto world. But which one is better? Hydrogen or battery-powered car? You can find out by watching our video that talks about the differences between batteries and hydrogen cars.